Right, so this is an infrared spectrum. You can see the x-axis is wave number. That's like a frequency of radiation. Transmittance is on the y-axis, so that means that all these things that are going downwards are called peaks, even though we might expect a peak to normally go up. We call them peaks. The first thing to be aware of is that anything below 1500 on any spectrum, you can pretty much ignore. This is called the fingerprint region. It is useful in some circumstances, but only if you have something to compare to. So if you think that something is a particular molecule, you can find its spectrum and compare it to it. But when we're trying to analyze the spectra, we just ignore that, don't care about it. So we only look at this bit. So you can see that we've got one major peak here. So it's just below 3000 wave numbers. So remember, the scale's going backwards. So these are low wave numbers up to higher frequencies up here. So we're just below 3000. So that's at about 2900. If you look on your data sheet, you will see that in the region 2850 up to 3100, we would expect to see a peak for CH bonds. Obviously, in organic molecules, we see CH bonds everywhere. So we'll see this peak in pretty much every spectrum that we look at. If we don't see it, it just means it's been obscured behind something else. So if you see a peak there, a sharp peak, you know it's going to be for CH. So looking at the next molecule, sorry, I should go back to that one. Because it's only got a CH peak, we can pretty much assume that that's a hydrocarbon. There's nothing else there. There is one other peak here, which is actually quite useful. So that peak is at around 1630-ish wave numbers. And if you look on your data sheet, you can see that for a hydrocarbon, the only thing that can be is a carbon-carbon double bond, which means that this molecule is an alkene. Next one along. So again, 1500 that way, we ignore, that's the fingerprint region, we're not interested. So we just have these two peaks here. So this one should be familiar from the last one. So it's around 2950-ish. That one is our CH peak, just as before. So it doesn't really tell us much, but this one here is quite useful. So the middle of the peak is here, so that's at about 3350 wave numbers. But what's also important is it's kind of a rounded peak. And if you look on your data sheet, you can see that for 3350, this is actually an OH peak, and on your data sheet it's labelled as alcohols or phenols. So it's an OH group, and it sits in that region 3200 to 3600. Now OH peaks that you will see will usually be alcohols or carboxylic acids. Carboxylic acids obviously also have the carbonyl peak, which you can see the data sheet would expect to see it around 1630 to 1820, so sort of here somewhere. You can see there's nothing there, so that's not a carboxylic acid. So this is an alcohol. So that's just a reminder that sometimes the absence of a peak is just as important as the presence of a peak. So moving on, let me just move this. Looking at this one now. So this one in lots of ways is quite similar. So again, 1500 that way, ignore, we don't care about it. That's the fingerprint region. Look for your CH peak first. So CH peak would be between 2850 and 3100, so sort of here. You can see that that peak there is your CH peak, but it's just that sharp peak on the end. This peak is a different functional group. So we're looking for the middle of it's around here, so around 3000. That peak is a very broad peak. You can see how wide the peak is. If you look at the top, it's really wide. At 3000 wave numbers. That's also an OH, but you can see it's a slightly different frequency to the alcohol, and that's because this one is due to a carboxylic acid. And we can confirm that because we have another peak here at around 1620-ish wave numbers. 1620 wave numbers is a carbonyl peak, so C double bond O. So the combination of C double bond O and OH means that this is a carboxylic acid. And another reminder that the OH peak was at a slightly different frequency, but they are pretty similar. The last one is this one. Again, 1500 that way, ignore, don't care about it. So this one here, that's at around 3000 wave numbers, will be your CH peak. So that just tells you it's got carbons and hydrogens, so not very useful. But this one over here, at around 1620 wave numbers, just like on the previous spectrum, is your C double bond O peak. So that's a carbonyl group. We don't have an OH peak. We do have something here. We don't really know what that is, but it's certainly not a broad OH peak that we would expect in a carboxylic acid. So this one is either a ketone or an aldehyde. We don't have enough information to know which one. One of those two. So notice that all I've been able to do from that is work out essentially what functional group each of those things has. We don't know anything about how many carbon atoms or molecular formula or anything. We just know the functional groups. So infrared spectroscopy is really useful for telling you which functional groups are present in a molecule. If you have more information like molecular formula or knowledge about what kind of reactions that it does, you might be able to find out even more information, but this is just a starter.